Yeah, so thank you very much. So I looked to the agenda and I saw this title, and first time I needed colors to get clear what this is. So this is a study, it's open source, and safety critical, and software unit development toolchain. And of course, you will learn how to make it safe and how to make it compliant, and also how to save money with open source tools and using them. And also you can save money by qualifying the tools, and you can also save money by avoiding of qualification of tools in a safe way, because the tools can detect the errors vice versa. So if you have 3 tools connected somehow, then the tools can detect the errors vice versa. So I like to start with a question: what is more interesting for you, to learn about the qualification of open source tools and save the money with the licenses, or to learn about the qualification avoidance within tool chains? So to the open source tool, so please raise your hand if you want to learn about open source tool qualification. Okay, and the avoidance of tool qualification, someone interested in that? Okay, those guys come to my booth, because today we'll talk about open source tool qualification. Okay, so we can talk also about the other things, but today it's clearly open source tool qualification and what's this about it. Yeah, the agenda will be, okay, I start with some requirements for beginners. I'm not sure how many safety experts we are here. Just to recapture, we all of the same state. And then I will, is this something? Oh, indeed, I can. So then we'll say something about the software unit tool chain. So what is a software unit and what tools are used? And then I'll show you how those tools can be qualified, just small examples that are qualifiable, and give you a summary. Yeah, safety of systems. We have ISO 262 says we have a system safety, we have hardware safety, software safety, tool safety. There's also data safety, which is not so a topic in ISO 262. And then, of course, standard compliance and safety integrity. And the safety integrity ISO 262 is rather a standard like a driver's license. So it gives you some obligations you have to have, and you need to make your driver's license, but it does not state when you are really a safe driver. So, and then that's safety integrity is like a prerequisite. So you can't be a safe driver without having a driver's license. So this is the main idea of it. And yeah, well, let's look to the motivation for tool qualification. Tools can have errors, and this is something we really observed. With a code generator, you have your model, want to do a simulation, and maybe simulation is not correct, but then you generate code, and then 1 and 1 is not 2 but 0. And then you say, oh, we have found a bug, go to the tool provider and say 1 and 1 should be 2. Guess what answer you get? Well, for our customers, it's more important to be fast and accurate. So for a safety perspective, this is very disappointing. And as Jörn said, you will have a safety manual, write it down and say, be carefully with this addition. 2 and 2 is 4, yes, but 1 and 1, you do some left and right shifting and performance optimization is 0. Well, can happen. We have even seen more critical effects. We have seen a test driver going into hospital because his car crashed due to a compiler bug. He optimized for space, and then he had a self-steering maneuver on the back axis and crashed and went into hospital. So he couldn't control the car due to a compiler bug. And these are things that can be avoided and have to be avoided by qualifying the tool and testing it from the safety point of view. Safety integrity is motivation number 2. So, and maybe it's a bit difficult to say, we are here in America, we have safety last. So if something happens, then people dig into it and then look, was it safe or not? I call this safety last. Usually in Europe, it's more safer to sell this, but I dare to do it here. And in Europe, we have laws like the UNHC regulations that force you have to prove your system is safe before you can bring it to the street. And currently, when you look to the full self-driving software of Tesla, here you can drive around, and I'll be happy also to test ride a Waymo. This is available here, but in Europe, I have to be driving a Tesla, calling them, if you have full self-driving, please give me a ride. And say, after half a year, they told, yeah, now we have a new software, you can take a test ride. It was so disappointing because they're just not allowed. And I have been in discussion with RDV from the Netherlands, where they're trying to get approval. And they asked me, Oscar, what shall we do with the tools? They claim we don't have any software, therefore we don't have any tools. But of course they do have software, and I will tell you how to find out which software they have and which tool they have. And then RDV was very happy to get this kind of lessons and discuss with me. Yeah, if you don't see, and we have seen safety managers going into prison because they have been lying about test completeness. And then Nairbeck killed a child, and who's responsible? Yeah, so they had a safety plan. We were testing it, and they didn't fulfill it. And also Uber was not accused to have killed a person, run over with a self-driving car. They have been accused to not following a safety plan. They had a safety plan with a safety driver, and they removed it. And this is something you can get accused. So this is some dangerous things, and maybe also motivation. So the first motivation, first motivation is safety, but many people are also motivated by compliance, and both is important. Yeah, how do these compliance and the risk reduction work? So you first identify the risks, and then you can measure, oh, my ADAS system is ASIL D, it's very critical. So the risk level is somehow going up the more critical your things are, and then you can do risk reduction. And risk reduction is expressed in ISO 262 in some tables. It says if you have ASIL D, it suffices to reduce the risk with statement coverage. If you have ASIL B, yeah, statement coverage and branch coverage is necessary. For ASIL D, you need to have branch coverage and MCDC coverage. MCDC implying branch coverage, of course. But this is somehow the more dangerous it is, the more you need to reduce it. That's pretty simple. Yeah, let me also introduce you different category of risks. So you know your system is ASIL D, yeah, but what does it mean for tools? ASIL D tool, and this is not the system. You know all ASILs, but there are also other classes. There's a class of libraries, and there's a class of software and of hardware. This is what you have in your standard approach. You have software, hardware, and systems, but you have also tools and libraries. So libraries are qualified according to I-12, which is software component qualification. And this is, the risk is shared. You see, there is one library which is used in different applications. And therefore, the safety standards allow you to do less. And this is important that is, you can, for example, omit the programming guidelines, because usually it's for open source library and there are no programming guidelines or no MISRA lines that are enforced, maybe others. And therefore, these are simplifications that are allowed. And for tools, the tools are defined by not going to the product. You see, the product has a combination of software and libraries in it, which is, of course, then more critical than the tools are. Nevertheless, we have to qualify the compilers and others. But you might also argue away some features, like the disassembler of a compiler. Can you qualify the disassembler? Of course not. It's not necessary because it's an uncritical part of the tool, and therefore we don't need to qualify the disassembler. Okay, these are the difficult, the different classification and categories. And for the tool category, we do a similar thing as we do it for the system. We analyze the risk and then we reduce the risk. Risk analysis is called tool classification. And it ends up not with an ASIL, it ends up with a so-called tool confidence level. And this so-called tool confidence level is computed in 2 steps. The first step is, has the tool an impact? The disassembler, if not used, has no impact. So you can say, no, this has no impact, and then of course it doesn't need to be qualified. The second, if it's a compiler, then it has an impact. And then you need to look to the different bugs. You might have an optimization bug, you might have an arithmetic bug, so you might have different kind of bugs, and you need to ask you, how likely is it that we detect the bug when we are testing? That many compiler bugs are detected, but some of them might not be detected. So therefore, you don't have a high detection probability for compiler bugs, but maybe not even a medium, but you might not know it. So then it's unknown. And then with this detection probability, you can compute the tool confidence with this simple table. So if you have no impact, meaning TI1, then it's TCL1. It's like QM, nothing needs to be done. or if you have TI2, which is an impact, then it depends on the detection. If you have a high detection probability of the potential tool errors, and you have also TCL1 like QM. But if you have a medium or a low detection probability, then you have like something like an ASIL D maybe. The most critical tools are like ASIL Ds. It's the same concept applied. It's just called differently. It's not called ASIL. It's called tool confidence level. And then you have here the different risk reduction methods. So first you analyze the risk, you measure the TCL, and then for TCL 2 and 3, you can look up here the risk reduction methods. And the risk reduction methods for ASIL D is, of course, validation, meaning testing, what is done using testing suites, and development according to a safety standard and proper combinations of this. So this is how the tool safety works. Yeah, what about TCL1? Why don't we reduce the risk? It's not reduced. Can we? And what does it mean if a tool is TCL1? If your tool is TCL1 means do not trust this tool. It's simple. If you someone tries to sell you a tool, and I have seen tool vendors saying you can use our tool up to ASIL D because it's TCL1. They were proud and said, no, that's not a good argumentation, because if you sell a tool as TCL1 means the tool user has to detect all potential error of the tools by using it so carefully, meaning don't trust this tool. So if someone outside tries to argue, yeah, it's not qualified, it's TCL1, we don't need, means TCL1 is don't trust this tool. It can be dangerous. Yeah, let's come to the main requirements of the tool qualification. And the first thing is 11.4.3. This is a requirement. It says you should use the tool as classified and qualified. So this is an important thing. And how can, let's say, an open source, or we provide you with an open source compiler, how can we ensure that you're using it as classified and qualified? You can do whatever you want. You can download it and compile it. Whatever. How can we ensure this? And the only way we can ensure this is every company has to have a functional safety manager. And I guess some of you are functional safety managers and are responsible. And you know about it. And responsible means you as a functional safety manager have control over your developers. And that's we explore. We just give you a tool safety manual. Say, dear functional safety manager, please ensure your developers are following this safety manual. And that's why Jörg mentioned, hey, you have to have a tool safety manual, and that's also the most important document. Of course, the qualification report documents that you have done everything correctly, prevents you from going to prison, whatever. But for the practical use, the tool safety manual is the most important document. Yeah, but now about the tool qualification. So the tool qualification has to be done in the environment where the tool is used. So if you at Ford qualify or buy a tool which is qualified, let's say under Windows operating system, and if you're building your Linux environment, who knows whether it's working there? Even if it's the same version, it can have different flaws. So therefore, it has to be done in the environment of you, and that's why we build qualification kits that you can run in your environment. But even more important than for compilers, the configuration of the tool is important. So meaning which kind of options you set. And every option combination can trigger different optimization rules. And every single optimization, and this also includes pragmas according to ISO. It's not me mentioning it, it's ISO. The configuration of the software tool has to be documented and has to be followed. So if someone tells you, oh, my compiler is qualified, you can use them. Yeah, qualified in which configurations? So there has to be a list of configurations that are qualified. And if this list is not present, I doubt they have tested all of them. And that's exactly where we need to be carefully looking to all this combination. So, for example, we work with Texas Instruments, and their compiler is pre-qualified, I think, for a list of 100 different combinations. So you can pick one of those pre-qualified combinations and use it on the right hardware they have done it. And if you have a different one, they will rerun it for you. So this is a proper way of doing it. Yeah, but not an infinite number of combinations. Okay, let's come to the software unit chain. So this is the V-like development of the classical ISO 262 part for the software. And here you see the units are on the bottom. So you have your requirements, safety concept, and your architecture, and then at the end you design your units and you implement them and you verify them. And this is somehow can be done with the software unit verification chain. But the question is, which tools do we need for that? Of course, you need a compiler. Yeah, software unit verification. You will also need a testing tool. But what else? Yeah, people will say, oh, yeah, we will need a build tool. We'll need something to make or ASIL or other things. But are we complete? Where do we know whether we are complete with our tool chain? And the answer is simple. Well, first, let me state the problem. So the problem is, which tools do we need to select? So we want to build software. And yeah, there are many tools. Some of them are critical. The red ones, the green ones are less critical. And how shall we define it? And there are many safety standards around. And there's quality, there's efficiency, there's price. So how shall we do this? This is a tool selection problem. And the answer is quite easy. It's a strategy. So the first thing you need to identify, what are you building? Is it an end-to-end AI system, or is it more a classical state-based system as we have seen it from Volvo, where you have some state machines being run and things like that? But the first question is also, what is inside? And you can look into the software. There's a memory map saying, on this address we have this software, on this address we have this software. And then you can ask yourself, okay, which are the safety standards we want to comply? Is it ISO 262 to be compliant with regulations? Is it SOTIF? Is this AI things? Is it maybe also cyber security? So you need to find out which standards you need to be compliant. And then you can look up to the compliance argumentation and into this table. So for example, ISO has this table, and I showed to you already, which coverage methods do we need? And then you can say, okay, for ASIL D, we have ASIL D. We need to have a tool that measures MCDC coverage. So it's not only the compiler, the build tool, and the test tool. Also, coverage tool is necessary, because otherwise we cannot argue like this. So the answer of which tools need to be used is can be found in the safety standards, because they say, okay, we need to have the methods that we need to use, and yeah, methods are used by tools and then are implemented by tools, and we can use them. For example, for unit verification, there is a table 7 that says you should for verifying unit to do those methods came into question, and everything with plus has to be applied. You see a walkthrough, yeah, well, this is only recommended, it's not necessary, but here inspection. Yeah, inspection is a manual process, no tool is required. But when it comes here to static code analysis, yeah, which tool do we use? We have to do a static code analysis. Do we just enable all the warnings in the compiler and qualify the compiler to do it correctly? I don't know, it's not so good idea. So better have a specific tool for that, and then we can determine which tool confidence level we have. So it's that easy, and I think that's all done for the static things. We have the cloud coverage tools, we have static code analysis, and of course we have a compiler, the build tool, otherwise it won't work. So then we have the list of tools that we need for unit testing. It's a compiler, it's a make or build tool, it's a Google testing framework. We need to be able to measure code coverage and have programming guidelines. So this is already the answer to this unit solution. You can also look to other parts of your system. And of course, if you're using a simulator and a code generator on the architecture level, this comes on top of those tools. Okay, let's have a look to the qualification of open source and all the tools together. The question, some people think, oh, it's open source, we do not need to qualify, we can trust it, we have confidence. No, it's not that easy. You also need to have the same thing, though. There is no difference whether to qualify an open source compiler or a closed source compiler. It's no difference. And in open source, you can maybe have more transparency to look to the code and implementation, but maybe when it comes to optimization rules, some closed source might say, no, we don't say you what we have done. Open source, you can just look into the code, and not so easy, not try to understand, but at least it's present. So you have to do something, and don't worry, Validas can help you with that. I don't have a single slide about Validas. I don't like so much the PR slides, but here at least I offer you some help. But we have a certified process, and this we can guarantee success. But how do we do this? We built a qualification kit, meaning something that runs the test in your environment. And this kit consists of a model. So we have, let's say, different models for different tools, but the principle is all the same. This model is then read by the qualification support tool, and this the support tool cooperates with the test automation unit that runs the test cases that are also part of the QKit, and gets the results back and generates the documentations, and that turns a red, a critical tool, into a green tool which is qualified. So there is no difference between the tool, but at least you have the required documents. So this is common to all the tools. And let's have a look to the compiler. So for the compiler, the model consists of the different features and drag bars and options and intrinsic. So what needs to be considered during tool qualification, and then of course it consists of the test automation unit with the debugger. You need to bring it to the target. By the way, this was generated from the AI, so it was the first attempt. I just said need a software testing tool, the debugger and the board, and then it generated this nice image. So, and I hint you to that as we have to do it in Europe. Yeah, and then of course we're using Supertest from SolidSense as we don't want to create new test cases for compiler that already exist. And we have this qualification support tool where you can enter the different parameters and configurations. Maybe you select the port on the board you run it and do this, and then it generates you the documents that are necessary, and that's it. And why do we do this? Yes, we have many findings and examples. Not only 1 + 1 can be 2, which wasn't even a compiler bug. Here are some compiler bugs listed. When you see here something like that, where the variable out is set to a value 4, and then it's overwritten by calling my function from 2. The compiler was very clever and said, okay, I don't use this variable 4 because out is overwritten here. But is this true? No, because it's calling my function, and my function is using the variable out. And if you set this here to 0, the result is 0. But if you set it to 4, then the result is 4. So somehow this function is not purely functional. It uses this as a side effect. Yeah, but the compiler optimizations, they make this kind of errors. And that's why we need to qualify it. And a lot of other things. Here, we just had a different patch level, completely different results. Nobody expected this, but hey, things can happen. Yeah, let's have a look to Basil. So Basil is a build system, and we offer a growing qualification kit. We don't cover all of Basil, but most parts of, or many parts of Basil. So here are listed some of them, and at the end there will be a qualification report, and those are the issues we know. For example, Basil, for some strange reasons, it does not consider the CXX options as it should do. So it is not correct, and we write this into the safety manual, and you can use those tools safely. Yeah, let's come to Google Test. Well, here's just a test report from Google Test. It's a cool framework. You can program it in C++ and just run the test cases. But hey, did you know it has problems with not a number and inf? When you want to have these corner cases testing? Yeah, then now you know it, but there are more things in the test suite. You see here also like a structure of these test cases. It's a handy framework for testing C++. Yeah, code coverage. This is, I think, the most important thing, because code coverage tools are usually commercial available, and you pay a lot of money for MCDC code coverage tools. And if you are a big company, you're having 100 or 500 testers, 500 testers times 10 or 15,000 euro. So then you are in the millions area. So what you are spending for those and those tools. And since 1.5 years, there is open source support for those coverage metrics available. But can you trust it? Can you really replace your commercial tools with open source tools here? Yes, you can, because we can qualify. We help you to qualify this. So for example, here you see testing code And these are the new options. So you can make a photo of it or look it up later. If you say coverage, condition coverage, and then you will run it, and then with the gcov command, you will get the MCDC coverage report from the open source tool. So it's like a compiler option. And when you compare this, and this is like an extension of the GCC compiler that does it, when you compare it with the traditional codings, then you will see that there are different errors. And here's one error where you see, for example, we have a tricky code, also tricky, with some constants in it, true or true and v2. And this compiler does an optimization and say it suffices to test it with true and false, but it is not, we cannot reach 100% code coverage because this term can never be false. So the maximal code coverage is 33%. But MCDC GCC says, well, we optimize away this constants and then it's 100% coverable. Well, but exactly you do code coverage to detect those kind of I would say shitty code, because it should not be like this. You should not program like this. And code coverage helps you to identify those kind of weaknesses. And in this case, it doesn't. So yeah, I wouldn't say it's bad, but at least you should know about it. And that's the idea of tool qualification. Okay, let's come to clang tiny. So we have, for example, here, it can detect infinite loops with some rules, and then it will warn you. And yeah, it also has known bugs that it does not do some things you might expect it to be done. Okay, in order to have some time for questions, I come to the summary. So the summary is tool qualification is mandatory. You can do analyze the risk, a bit like an ASIL is done. And we have qualification kits that you can qualify compilers together with SolidSense, Basil, Google Test. MCDC code coverage is working for clang-based compilers and for GCC-based compilers. So you have the choice. And with clang tiny, you can qualify your static analysis rules. Yeah, it's TÜV-based certificates. And if I would recommend you something, then really look to your tool chain, whether it's complete or not. And here you see what we call the tool readiness check. So it's just half an hour talk with me, and then we go through the tables in ISO 262, as I have shown you, either for the unit test part here or for others, and then you will see whether you're ready or not. And this is something we do as a get to know Validas offer for free. Okay, now I'm done. Thank you very much, and I'm open for questions.
Thank you. Yeah, we can go for a couple of questions from the audience.
So yes, I have a question. Right? So you said like open source tool, there's a way to qualify them. And I also heard there's argument that people can make for like using a commercial off-the-shelf kind of thing. So which is meaning like using something that is like already being well used in the wild. Does that still need to go through the tool qualification to, you know, like a TCR1 or TCR3 to be able to consider to be, you know, generate some artifact for like an ASIL, like a compliance system?
Yeah, very good question. So ISO 262 considers this. So we have seen, of course, you need to classify the tool, even if it's something you say commercial off the shelf or something. Or here's the slide. Sorry, here's the slide. And the slide says you have 4 different qualification methods. I didn't explain them all, but one is increased confidence from use. You can say, okay, I know this tool very well, and it's working since 5 years. We always use the same version. It's quite stable. We know the known bugs, everything good. This is a valid qualification method for ASIL A and ASIL B applications. For ASIL C and D, it is not sufficient anymore. So for ASIL C and D, you need to do more than having just this confidence from use, which is one qualification method mentioned in ISO 262. But very good question.
Is that your standard prove it in use argument there?
Yeah, this is similar. Like it's not proven in use; it's confidence from use. So proven in use somehow is replaced by this confidence from use, but it's a standard thing and it's applicable to ASIL A and B. Yeah, of course.
You said that those tools at gcov and LLVM Gov, they can be qualified.
Yes.
It's not qualified currently.
No, it's not directly qualified. You have to qualify it in your environment.
Mhm.
And to see whether, for example, when you use GCOF, you need to know that it's cooperating with your compiler and your reports and things like that. So it's
The whole thing with the whole system of qualification is like,
it has to be sure it has to work in your environment. It needs to work. So it doesn't make sense if we qualified, of course. And that's, by the way, a good point. We also, and Solid Science does the same, pre-qualified tools. So we can qualify it for us, and then you give your virtual machine and this is working, and then you can use this virtual machine to have the tool qualified already. So this is something, connect to the right board and you're done. This code coverage, it's also need to be measured on the board.
can consider this bullseye tool to be part of this list.
What? Bullseye?
Yes.
Yeah, Bullseye is a code coverage measurement tool that gives you code coverage. To my knowledge, so some years ago, they did not have MCDC code coverage. So they have
They don't know.
They do know. Okay, well then this is also something that I'm not sure if they have a qualification evidence that is working correctly. But if so, then you can also use Bullseye, of course.
I think in the interest of time.
Okay, so then thank you very much.
That's good.
There is also a podcast about tool and library qualification that we do run. If you have more questions, or just come out to booth number 8 and in the exhibition. So I'm happy to answer you the questions, how to reduce the qualification need in tool chains. So I couldn't talk about this today. Thank you very much.
Thank you.